right, so let's do an example. So we have in this figure right here, a rescue plane flies at 198 kilometers per hour, which is 55 meters per second, and constant height h, which is equal to 500 meters, toward a point directly over a victim where a rescue capsule is to land. We want to know A, what should be the angle phi, I think, phi, of the pilot's line of sight to the victim when the capsule release is made, and then B, as the capsule reaches the water, what is the velocity v? So what's happening here is we have a plane that's coming like this, and it's releasing a capsule. All right, so basically what happens, this is basically a horizontally launched projectile, because as the plane releases the capsule, that capsule, because it has what we call inertia, which again we'll talk about in the Newton's laws unit, but because of that, it's going to continue going at the same velocity in the horizontal direction that the plane is going. So what this tells us is that this initial velocity in the x direction, which remember the x direction velocity is constant, so I'm just going to label it Vx, that's going to be our 55 meters per second. Now, what else we can know here is that because that plane is dropping that capsule, because they're dropping it, just like we do with free fall problems, we can just say that the initial velocity in the y direction is 0. So initial velocity in the y direction equals 0, okay? Now, let's think of our game plan here. Now, we want to know what this angle right here is. Now, we know the height is 500 meters. So if we can find that delta x, or that range, right, the horizontal displacement that package goes, then we can use our tangent, inverse tangent, because we then know our x component of that triangle and the y component of the triangle as well. All right, so we need to know what delta x is. Now remember, the only equation that we use in the x direction is that Vx is equal to delta x over time, because we have a constant velocity in the x direction. So we can find what delta x is if we find time first. So need time first. All right, sorry, my writing is so messy, wow. Now, you'll see that in a lot of these problems, we will be given information for one direction, either the x direction or the y direction, and then what we need to do is we need to find time from that information in order to solve what we actually want to solve for. So you'll see that a lot of the time we need to find time. So we know in the y direction that our initial velocity is 0. We also know that the acceleration is a negative, I'm going to call down negative, 9.8 meters per second squared. We also know that that package drops a vertical displacement of 500 meters. So because of that, I'm going down, and I said down was negative, so my displacement in the y direction is that negative 500 meters. And remember, from this information, we need to find time. So because of this, we can use a second basic equation. So we get delta y is equal to initial velocity times time. And remember, this is the initial velocity in the y direction, because we have to split these two directions up, plus 1/2 times the acceleration in the y direction times time squared. Now I know that the initial velocity in the y direction is 0, which makes our calculation a little bit easier. Our displacement in the y direction is that negative 500 meters equals 1/2 times acceleration, negative 9.8 meters per second squared times time squared. And so I get negative 500 equals a negative 4.9 times time squared. I'm going to divide both sides by negative 4.9. And we get that time squared is equal to 102.04. And then we are going to take the square root of both sides in order to get our time. So we get a time of 10.1 seconds. So now that we have the time that it takes that package to get to that victim, we now want to plug that time back into our x direction. So Vx is equal to delta x divided by time in order to find our range or displacement in the x direction. So we get delta x is equal to Vx times time We know that the x velocity is 55 meters per second. It was given in the problem. And then time we just found to be 10.1 seconds. So that means that our displacement in the x direction times 55 is 555.6 meters. All right, so are we done? No, we're not. We now need to find that angle, right? So we know now that this is 555.6 meters. And so now we can use our inverse tangent in order to find that angle. So tangent to the -1, inverse tangent of opposite, which is 555.6, over adjacent, which is 500. And we end up getting that our angle, the answer finally for this letter A is 48 degrees. Right, so that's our answer for letter A. And then letter B, it says, as the capsule reaches the water, what is the velocity v? So we now want to find the final velocity at the bottom. Now, when something is shot out in the horizontal direction like this, and then it's going to hit the ground down here, or hit the water in this case, it's going to hit the water at an angle. All right, so what we need to do in order to find that final velocity, we need to find the y component and the x component, v final y and v final, no, not v final, sorry, vx and vx, in order to then find that final velocity. Okay, so we already know what vx is. We know that this is 55 because we know that in the x direction there is no acceleration, and therefore we're moving at a constant velocity in the x direction. So all we need to do here is we need to find the final velocity in the y direction. So we're going to use one of our constant acceleration equations. I personally like the first one, the first basic equation, just because the calculation is pretty easy. So we get v final y equals v initial y plus acceleration times time. Because we know all of the other variables, you can really pick any equation that has v final in it. So v final y will be equal to 0. Remember, we're dropped in the y direction, plus negative 9.8 meters per second squared times time, which was 10.1 seconds. So we get our final velocity in the y direction is 9.8 times 10.1. 98.98, and that's a negative 98.98 meters per second. And then we have our x direction. So now in order to find that final velocity in the y direction, we're going to use Pythagorean theorem. Now here, remember, that is a negative number because I said downward is negative and it's moving downward, right? That final velocity in the y direction is down, which makes sense that we got a negative number. So to find the final velocity, we want the square root of that 98.98 meters per second squared plus that 55 meters per second squared. So I get this squared plus 55 squared, and then take the square root of all of that, and we get that our final velocity is 113.23 meters per second. All right. Now, did it want the angle also? Just says, as the capsule reaches the water, what is the velocity v? So all they asked for is the final velocity. So there's our answer for final velocity. Now, they could also ask, what angle does it reach the water at? So you can also find the angle if they wanted you to do that.